Hey class, how's it going? Um, so we are now going to start our distance learning for physical science. And with that, we're going to go back in the textbook and I'm going to go to chapter 14. And one of the things I most want to talk to you about this whole year has been how atoms and how matter works. And so we're going to start our unit with solids, liquids, and gases, which are ways that matter can exist that you're probably more familiar with. And I guess with that chapter, first part of this chapter, it deals with how thermal energy can control what they exist as. First question is, by this beverage here, what state of matter is this? Did you pick all three? Because there's obviously the drink itself, which is a liquid drink, but then there's ice in there, and ice is what kind of matter? Yes, it's a solid. And there are bubbles in there, and there are bubbles are gases, right? So they're all three are there. And with gases are the most defined by or recognized by how they're controlled by kinetic theory. Remember, kinetic means how things move. And what you need to realize here, kinetic theory with molecules, with states of matter, and gases particularly, deals with how that matter. The first thing you have to realize is that they're all made of matter. And matter being they're made of atoms. And with all objects, with all atoms, they have energy in them, and the energy means that they're always going to be constantly vibrating a little bit or constantly moving, and they'll be moving more or less depending on how much energy they have. With gases, they have so much energy, the particles will collide with each other like bumper cars in a bumper car arena, and they bump and go other ways, bump, go this way, go this way, go this way. So they'll be all through the container they're in, meaning that they don't have a definite volume. The volume is determined by what container they're in. You put a liquid into a container, the volume is just going to go to the bottom and rest. Put a gas into a container, it's going to spread out and fill up the container. So its volume is not controlled. And I guess another thing about gases is that because the particles don't actually collide and make contact, they get close and repel each other with the charges, that not much energy is lost, and so it'll stay a gas for pretty much ever, like for long enough that we don't even worry about it. But in a liquid state, because the particles don't have as much kinetic energy, that it moves as much, they'll be held together by little bonds, and as the bond's not strong, they're trying to break free from each other. They're trying to. And so if you put your hand down into a fluid, you can easily break those bonds. Your hands get in there. So the volume of a fluid, the volume is determined by, 1 liter of fluid is 1 liter of fluid. It's not going to pour 1 liter of fluid into a beaker. It's not going to fill up the beaker, and if it's a 2 liter beaker, it's not going to fill it up and leave it. And it's going to rest at the bottom at 1 liter. But the shape of it is determined by the container it's in. So volume is set, but shape is still changeable. Well, solids, they're still vibrating, but they're vibrating so with such little force, because there's such little energy there. They're held together. They're locked together. So the shape doesn't change, and thus their volume doesn't change. Because of kinetic energy. There's not enough energy for them to move apart from each other. And here you can see that it's thermal energy that gives the particles their kinetic energy. Thermal energy is what? What's energy from heat? And all particles have have heat, and the more heat they have, the more they vibrate. And so what happens to water when it vibrates with a lot of energy? And what happens to water when it vibrates with less energy? Temperature is, so all the particles are moving there, and they'll have their own little bit of movement, and it will be different by somewhat to each other. But the average energy they have, average kinetic energy that make up that substance, we call temperature.